Lesson 10.2, we're focusing strictly on arithmetic sequences and series. All right, so the first thing you'll see is the formula for the nth term of the arithmetic sequence. So let me explain what each of these variables represents. an, that is the nth term of the sequence. So if we plug in 7 for n, then an or A7 is the 7th number in the list. If we plug in 12 for n, then A12 is the 12th number in the list. A1 is the first number in the list, or the first term. D is the common difference. So how much is being added to get to the next number? You could find D by taking the second number and subtracting the first number. And then n, so n is a little confusing. N is not the number in the list, it is that number's spot in line. So if I say 2, 4, 6, 8, 10, so 10 would be A5. The n for that item would be 5. So again, 2, 4, 6, 8, 10. Let me write that down. So let's make a very short list. All right, so for this item in particular, that is A5, and the n for that value is 5. All right, let's do some examples. All right, so when you are finding the formula or the equation, you want to leave an alone and leave n alone. So an and n, if possible, do not plug in for those items. All right, so an I want to leave alone. A1 is the first item in the list, 30. All right, so to figure out D, you can probably just look at it and tell. If you need to, you can do this work. You take the second number, subtract the first number, and you get -10. So D is -10, and you could tell because the items are going down by 10. All right, so plug -10 in for D, leave n alone. All right, and then just simplify. All right, so we have 30 minus 10n plus 10. All right, so you could write 40 minus 10n. I prefer when it looks similar to mx plus b. So I'm going to write -10n plus 40. All right, number 2 is pretty similar. So we write an equals, the first item I see in the list is -6. All right, let's figure out D. So you take the second number and subtract the first number. -1 plus 6 is +5. And as you can see, the numbers are increasing by 5. So D is +5. We don't plug in for n. Now we just simplify. -6 plus 5n minus 5. So an equals 5n minus 11. And if you want to double check your work, if you plug in 1, you do get -6. If you plug in 2, you get -1, and so on. All right, on number 3, we're finding a specified term. Now, usually you need to find the formula for the sequence first, but notice it's actually the same list as number 1. So let's just use the answer to number 1 to figure out A12. All right, so we're finding A12, -10, but n is 12. And looking back at number 1, make sure that n does not look like a subscript. All right, so -10 again times 12, and then plus the 40. So A12 equals negative 120 plus 40. A12 is negative 80. So if you were to expand the list to 12 items, the 12th item would be negative 80. All right, number 4 is the same sequence from number 2. All right, we definitely don't want to expand the list to include all of the first 100 terms. So let's only find the 100th term. So n is 100, 500 minus 11. So the 100th item in this list is 489. All right, the directions on number 5 say find the arithmetic means. That basically means just fill in the blanks. Okay, so notice there are 3 missing terms, but what I like to focus on is how many jumps it takes to get from the 21 to the 45. So if I'm at the 21, it's 1, 2, 3, 4 jumps to get to the 45. All right, so then what I do is write 4D equals 45 minus 21. So basically, we had to add the common difference 4 times to 21 in order to get to 45. So 4 common differences increased our term by 24. So that means 1 common difference is 6. And now we just go back and we add 6 to each previous term. So 27, 33, 39, and those would be the answers. All right, so again, I'm going to count the jumps. 1, 2, 3, 4, 5, 6 jumps. So 6 common differences. And then this tells me how much it increased. 6 common differences led to an increase of 54. So each common difference is 9. And now let's just go to the blanks and add 9 to the previous term. Negative 9, 0, 9, 18, 27. And you could check your work by, if you add 9 again, you do get 36. All right, so now we're learning about a series. So we've been talking about sequences. A series is what you get when you add up the items in a sequence. So again, the sequence is just the list of numbers. A series is when you take the list and you add them all together. All right, so there's a story behind where this formula came from. So the way the story goes is the mathematician Friedrich Gauss, apparently when he was in 2nd grade, his teacher asked him to add up all the numbers from 1 to 100. So I'll just write 1 plus 2 plus 3 plus, and I won't write them all, dot, 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 plus 98 plus 99 plus 100. And so the teacher thought that'll keep him busy for a while, but then the future mathematician figured out the answer pretty quickly. And so the way he did it was he realized that 1 plus 100 is 101, 2 plus 99 is 101, 3 plus 98 is 101. So all of these pairs are going to add up to 101, and then we just need to know how many pairs there are, And so there will be 50 pairs because if there's 100 items, 100 divided by 2 is 50. So looking at the formula, this part here, the n over 2, that represents how many pairs of numbers there are. So in this example, there's 50 pairs because there's 100 total. And then the inside represents what each pair adds up to. So in this example, 1 is A1 and 100 is AN. So each pair added up to 101. All right, so using that formula, you might notice that you don't initially have everything that you need to plug in. All right, so if I'm trying to plug in, I actually get stuck right away. So I write S, and then I can't even write the N in the subscript because I don't know how many items are in the list. All right, so what you could do is you can plug into the other formula that we were using earlier in the lesson. All right, so using the AN formula, right, so I guess I'll write the formula again. So we know this formula, AN equals A1 plus D times N minus 1. All right, so AN is 100. A1 is 2. Looking at the list, the items are increasing by 2, so our common difference is also 2. And then what we don't know is how many items are in the list. All right, so we're trying to solve for n. The first thing I would do is subtract the first 2. All right, a lot of people would be tempted to distribute here. If we're trying to get n alone, we don't want to invite another number to come, stand next to n. So let's divide that outside 2. All right, and now we could see that n equals 50. All right, so now I could go back to the sum formula. We're finding the sum of the first 50 items in this series. All right, so S50 equals, well, how many pairs of numbers are there? If there are 50 numbers, that means there are 25 pairs of numbers. And what does each pair add up to? Each pair adds up to what A1, the first term, and the last term add up to. So this ends up being 25 times 102. 25 times 100 is 2,500. So then 25 times 102 should be 2,500 plus 50. All right, so again, they asked us to find the sum. Now this time I do know what n is right away. They tell you n is 10. So n over 2 is 10 over 2. Then we need A1, which is negative 8, plus, and now we're stuck because we don't know AN. All right, so let's plug into the other formula. We want to know what AN is. So we're finding A10, which is negative 8 plus, actually, minus 7 times n minus 1 or 10 minus 1. All right, so A10 equals negative 8 minus 7 times 9, negative 8 minus 63, which is negative 71. All right, so negative 8 plus negative 71, this becomes 5 times negative 79. Negative 79 times 5 is pretty close to negative 400. Should be negative 395. All right, for For number 9, they want the first 3 terms. So we want A1, A2, and A3. And actually, one of them is already given to you, so we really just need A2 and A3. So I'm going to start with the sum formula since they give you Sn. So plugging into the sum formula, I'm not going to write Sn because I already know what the sum is. So Sn equals n over 2. Now, I don't know what n is, so I'm just going to write n. But I do have everything else in the formula. So Sn equals n over 2 times A1 plus An. So if that's the only thing missing, we can solve for it. So 430 equals, all right, I'm going to do 2 steps in one. This is 86. 86 divided by 2 is 43. So 43n. So n equals 10. And now, if we know A1, the way we find A2 and A3 is by adding the common difference. So now we need to figure out what the common difference is. So now we could use the AN formula. Now we already know AN. AN is 79, so the formula is AN equals A1 plus D times, and then we just found n minus 1, or we just found n, which is 10, and then the formula has n minus 1 or 10 minus 1. All right, subtracting these 7, I get 72 equals, and then I'm going to take d and multiply it by 10 minus 1, so 9d, so d equals 8. All right, so now I can answer the question finally. A1 was given. A1 was 7. And if I add D, A2 is 15, and A3 is 23. All right, and the next thing we're learning is sigma notation. So over here, this is the Greek letter sigma. That's actually capital sigma. And in chapter 11, you'll learn lowercase sigma, which is standard deviation. All right, so we're doing capital sigma. Capital sigma means you're going to be finding a sum. So you're going to be finding some items and adding them together. All right, so they want us to write it in expanded form. So I think the math is pretty easy. It's just teaching you this notation. All right, so what this means is we have this function, and we're going to plug in a few different values into n. So underneath the sigma, that tells you the first item to plug in to n. So if you plug in 4 right here, 3 times 4 is 12. 12 minus 2 is 10. All right. After 4, you're going to plug in 5. So if you plug in 5 right there, you get 15 minus 2. That is 13. Then you're going to plug in 6. So if you plug in 6 for n, you get 16. 16 is 18 minus 2. And then you're not going to keep doing this forever. The number at the top tells you the last number you're going to plug in. So we plugged in 4, then 5, then 6. The last one we're going to plug in is 7. So if you do 3 times 7 minus 2, that is 19. All right, so they don't ask us to actually find that sum. They wanted it in expanded form. So that's expanded form, just showing what items are going to get added together. All right, so on this one, the first value we're going to plug in for j is 0. Then we're going to plug in 1, then 2, then 3. All right, so if I plug in 0, I end up with negative 1 to the 0 is 1. and then the bottom would also be 1. All right, I'll simplify that later. All right, so that's what we got when we plugged in 0. Now we're going to plug in 1 for j. So if you plug in 1 for j, you get -1 over 1 plus 1 is 2. So again, this is what we got when we plugged in 0. This is what we got when we plugged in 1. Now let's figure out what we get when we plug in 2. So -1 squared is +1. And then the denominator would be 2 plus 1, or 3. All right, and then finally, what do we get if j equals 3? So it'll be -1 to the third is -1. And then the bottom would be 3 plus 1, or 4. All right, so making this a little nicer, our expanded sequence would be 1 minus 1/2 plus 1/3 minus 1/4. All right, so this is a much longer list. Good thing we're not expanding it. We're just going to find the sum. So there are shortcuts we can use. So if we're starting at 1 and going to 18, we are finding the sum of 18 numbers. So there are going to be 18 items that we're finding the sum for. However, we know that there's a shortcut for finding the sum. So we're finding the sum of a list of 18 items. So it's S18. Formula is n over 2. And then we only have to plug in the first and the last number. So if you plug in 1 for k, you get 3 plus 4. So you get 7 when you plug in 1 for k. If you plug in 18 for k, you get 3 times 18 is 54. 54 plus 4 is 58. All right, so this sum is going to be 9 times 65. 9 times 60 is 540. 9 times 5 is 45. So this should be 585. All right, for the other sigma notation problem, you have to be careful. You have to be careful figuring out how many items there are. So the common wrong answer is people think, if I'm starting at 18 and going to 42, they think that's 24 items. It's actually 25 items. So the way to think about it, if it was 1 to 42, that's 42 items. So you don't just do 42 minus 1. You actually do 42 minus 0. So if I want to include 18, then the math I should be doing is 42 minus 17. So again, I don't do 42 minus 18 because I want to keep 18. So I do 42 minus 17. So kind of imagine, what if the teacher told you, read pages 18 to 42? So that just means you're not reading the first 17 pages. So it's actually 25 pages you would be reading. All right, so S25 equals 25 over 2. And now plug in the numbers. If you plug in 18, you get 72 minus 9, which is 63. If you plug in 42, you get 168 minus 9, 159. All right, so this is 25 over 2 times, looks like 222. All right, so I'd probably give you a calculator for numbers this ugly. You get 2775. All right, and now we have a couple challenge problems. All right, so what's tough about this problem, if you think back to the formula, there are 4 variables in that formula. So ideally, you'd be given 3 out of the 4, but we are not given 3 out of the 4. We're not even given 2 out of the 4. The strategy I've found to be the most helpful is basically ignoring, in this example, ignoring the first 7 numbers in the list. So what I like to do is pretend that the smallest term, in this case A8, is actually A1. Right, so I'm changing that to A1. Now notice, if I go from A8 to A1, I'm decreasing the n by 7. So if I just decrease them all by 7, it actually becomes a much easier problem. So then A12, if I decrease it by 7, or if I decrease the subscript by 7, this is now A5. And now we're looking for A33. All right, so now I'm going to plug into the formula. So I'm trying to find A33. That equals 60 plus, now I don't know what D is just yet. All right, so I'm going to leave that blank for now. And then I'm going to plug into this formula one more time using just the things we do know. So I know that. So now I'm pretending that A5 is AN. 48 equals 60 plus D times 5 minus 1. Right, 60 plus 4D, negative 12 equals 4D, so D equals negative 3. Right, so now going back over here, I know that D is negative 3. So it's A33 equals 60 minus 3 times 32. 60 minus 96, which is negative 36. All right, and I wrote A33 pretending that I never made those changes. It's actually A40. All right, in the last problem, we're going to write our own sigma notation for positive 2-digit numbers that end in 2. All right, so I won't write the whole sequence, but just to get an idea of what we're trying to find, the first positive 2-digit number that ends in 2 is 12, and then 22, and then 32, and then keeps going on this pattern, and then the last number in this sequence would be 92. All right, so using sigma notation, all right, so 3 things we need to fill in. So one is, where do we start? So I usually like to start with n equals 1. And then I can tell there's 9 items in the list, but let's say you're having trouble. So what you can do is plug into this formula and figure out what n is. So 92 equals 12 plus, right, common difference is 10 because the numbers are going up by 10 times n minus 1. So we have 80 equals 10 times n minus 1. 8 equals n minus 1. So n is 9. Right, so there's 9 items. Right, and then next to that, we need to figure out a formula. All right, so a couple strategies you can use. The strategy I was using in the last lesson was I figure out what the slope is. The numbers are going up by 10, so I write 10n. And then looking at what I've written, if I plug in 1, I do not get the first item that I want. So I need to increase by 2. Right, so that's one way. If you're not comfortable with that method, then you could also basically do what we did on number 1 in these notes. And right, so I'll just do it up here. You could try to write the equation. So it's an equals a1 plus d is 10 times n minus 1. So this is a way you could figure out the formula. 12 plus 10n minus 10. So an equals 10n plus 2, which is what I just found. This is not the only possible correct answer. So maybe you're able to come up with something like this, starting at 0, going up to 8, and then all right, so if we started with n equals 0, then the answer would be 10n plus 12. All right, so there's more than one correct way to do this. I think I like this one the best. I think that's the easiest for you guys to obtain. All right, that is all for 10.2.